Good day friends. Today we are going to see about the page replacement algorithm in operating system. Now here we are going to see about the page replacement algorithm, that is what is it, then the three algorithms which are used in page replacement, first in first out, optimal page replacement and least recently used. Now before that we will just recall the previous things that what we have studied in the earlier section. First one is the virtual memory management. In virtual memory management we have already discussed about the demand paging, demand segmentation and paging considerations. Today we are going to see about the page replacement algorithm, which is a part of a virtual memory management. Now we will see about the page replacement algorithm. First we will see why do we need the page replacement algorithm. Now what is the actual purpose is, now the physical memory we will be storing all the pages. Now suppose if the physical memory is filled and all the pages have been loaded, and suppose I want to add a new page in it, where do we fill it? So at that time we have to replace the page which is not needed through the with the help of the page replacement algorithm. Okay. So the main concept of the page replacement algorithm is to reduce the page fault. So the page fault should be reduced with the help of the page replacement algorithm. So for doing that we have to evaluate the algorithm. So we evaluate the algorithm by running it with the particular string of memory references, which is called as the reference string, and we are going to compute the number of page faults which occur on that particular reference strings. Now here just we will see about the graph of the page fault as well as which occurs with the help of the number of frames. Now see here, the number of frames, as the number of frames increases, the page fault decreases. This is the general concept which we are going to see in the page fault algorithm. Now first we will see about the first in first out algorithm. This is the first algorithm, and here the main concept of first in first out is that the oldest page has to be replaced. Now how this can be done, we will see with one example. Now see here, the page replacement algorithm, with the help of that the reference string is given 701203, the full thing is the reference string, and we are going to apply the first in first out algorithm in this particular reference string. Now the frames are 7, 0, 1, 2, 0, etc. Now here see the first one, the page. The pages are, as we already know, the pages will be divided into many frames. Here we have divided the page into 3 frames alone. Okay. So now first we are going to see, we are going to load the page 7 in this frame. Now since the particular page 7 is not available here, we are considering this as a page fault and we are loading the number 7. The next one is the 0. 0 page is also not available in the physical memory. So we are considering it as the next page fault and we are loading it down. The next one, 1. Particular frame 1 is not available in the physical memory. So we are again considering this as a page fault and loading 1. Okay. The next one, the next reference in the reference string, the next frame is 2. Now here see, the physical memory is already filled and there is no space in the physical memory for that particular frame to be loaded. So here we have to replace the page. So at this particular time the first in first out concept will come. So first in first out mean, as you know, the first frame which has been loaded in the particular physical memory has to be replaced. So automatically the frame 7 is to be replaced by the page 2. Okay. So 2, 0, 1 is now available in the physical memory. The next frame in the reference string is 0. Now 0 is already available in the physical memory, so there is no need for any replacement. The next frame is 3. 3 is not available in the physical memory. So what we have to do is the next frame which is already loaded in the particular physical memory has to be replaced. So when we see that 201, the 0 is the second frame which is next loaded. So we are replacing 0 with 3. So 231. In this way the particular all the frames in the reference string has to be loaded in the physical memory one by one. So at the particular number of times the page frames are there, it gives us the page fault. So in this particular example the page fault is 15. Now see here, the next reference string is given as 1, 2, 3, 4, 1, 2, 5 and so on. Now for this particular reference string, suppose if in the physical memory I use only 3 frames, the number of page fault which occurs is 9. Okay. Suppose in the physical memory the number of page frames I have used is 4, that is if I increase the number of frames, the page fault also increases to 10. Okay. So this type of, that is in the graph we have already seen, in the previous graph just we have seen if the number of frames increases, page fault should decrease, that is the page replacement algorithm. But here just opposite thing occurs, that if the number of pages increases, the page fault also increases. So this type of mismatch, it is called as the Biladi anomaly. Okay. So the number of frames increases, the page fault also increases. This is one of the disadvantage of first in first out method, and it is then replaced by the next algorithm called as the optimal page replacement algorithm. Optimal page replacement algorithm, it is also used for replacing the page, but it will choose the page which is not used for longest period of the time. So that is the main concept of optimal page replacement. Now we will see again the same reference string and how it can be used for the optimal page replacement. Now here again if we see, first in the first 3 frames should be loaded in the physical memory and the page fault occurs each and every time. So 701 will be loaded. The next frame 2, when it comes, which frame has to be replaced, which is not used for the longest period of time in the future. So if we see after 2, if we go, the frames will be 0, 3, 0, 4. 2, 3 and so on. So 0 is again referred, and if we see 1 is also again referred, at the end only 7 will be referred. So at this time 7 is the page which is not used for a longest period of a time. So that 7 page has to be replaced by 2. Okay. In the same way, next if we see, the next frame will be 0, it is available in the physical memory, so no need of any page fault. Then if we see, the next string will be 3. Now the 3 where it has to be replaced, if you see the next future frames will be 0, 4, 2, 3, 0, 3 and so on. So at the end only we will be getting 1, 2 and 3 are referred for the future time. So after that only the particular frame 1 has to be replaced. So we will be replacing the 1 frame with the frame 3. So in this way the particular frames, all the frames in the physical memory has to be referred, and in this particular algorithm the page fault which occurred is 9. Okay. So the next algorithm, now we are going to see about the next algorithm, which is least recently used algorithm. It will be same as it will be just the same as the optimal page replacement, but what is the thing here is, the particular page which has not been referred for the longest time in the past should be considered. In the OPR, we are considering the frame which is not used in the future, but in least recently method we should use the frame which is not used in the past. Okay, that is the main difference between the optimal page replacement and the least recently used algorithm. Okay, next we will see the example for the same reference string. Now how the LRU method is used. See here, the 701 will be replaced, as you know already. The second, the frame 2, when it comes, the page which is not used in the past for the long period should be replaced. So if we see, 1 is referred in the past, 0 is referred in the past, but the last frame which has referred in the past is 7. So 7 should be replaced by the page 2 which has to be now loaded. Okay. So page 2 is loaded, 0, 1 is there in the physical memory. Next if we see, the next frame is 0, 0 is already in the physical memory, so no page fault occurs. Then the next frame 3. 3 if we see, again the same thing. In the past we have referred 0 as well as 2, then only we have referred 1. So the page which is lost been used in the past is 1. So we are replacing page 1 with the page 3. In the same way, for all the frames we should load it. So the number of page fault occurs here is 12. Okay. So this is the main concept here. So we will just recall the particular things. In the page replacement algorithm there are 3 techniques, that is there are 3 algorithms which are used, first in first out, then optimal page replacement and least recently used. Here in all the 3 algorithms we are calculating the number of page fault and the page fault which is minimal, that particular algorithm is best for the reference string. So, for all the reference strings the page fault may be different, but we have to choose the particular algorithm which has the minimal page fault for the particular reference string. I hope all of you understood about the particular page replacement algorithm. Thank you.